In the world of space exploration, risk is part of the process. SpaceX, one of the most ambitious companies in the industry, knows this better than anyone. With Starship, they're creating the largest and most powerful launch system ever designed. And because of that scale, every test comes with big rewards and big risks. Recently, one of those tests ended in a dramatic explosion. But what happened next shows just how serious SpaceX is about learning fast and moving forward. Given Starship's role in future Moon and Mars missions, something major has just happened that could have delayed everything. In this video, we'll look at the Ship 36 explosion, how SpaceX responded, and what it means for the next Starship flight. But before we go further, make sure to subscribe so you don't miss more updates from the world of space. On the night of June 18, 2025, just before midnight in Texas, Ship 36 exploded on the test stand at SpaceX's Starbase facility. The rocket was being fueled for a major static fire test involving all 6 of its Raptor engines, but before the engines even fired, the vehicle blew apart in a massive fireball. The cause? A failure in one of the pressure tanks. These are called Composite Overwrapped Pressure Vessels. They're high-pressure containers, and Ship 36 had one filled with nitrogen located inside the nose cone. During the fueling process, that tank burst. It was the first time SpaceX had ever seen a pressure vessel's failure on a Starship. And when it went, the rest of the rocket didn't stand a chance. To be clear, this wasn't a problem that spread to other systems. The pressure vessels used in Starship are different from the ones in the Falcon 9 rockets. That means Falcon launches, like Starlink missions and international crew flights, are not affected by this issue. It's isolated to Starship, which is good news for the rest of SpaceX's operations. Right after the explosion, SpaceX locked down the area and began safety procedures. All fires were quickly put out, and SpaceX confirmed that everyone on site was safe. No injuries were reported. Since static fire tests happen with only essential personnel nearby, most people were already kept away. Local emergency officials joined SpaceX crews to secure the site and check for any environmental damage. Thankfully, the materials used in Starship are not toxic. SpaceX said the steel hull and propellants pose no chemical or biological risk. Based on earlier tests, no contamination was expected, and agencies are still doing environmental checks to confirm that. As the investigation started, SpaceX engineers began reviewing telemetry data and inspecting the debris to understand what exactly caused the tank to fail. Musk called the event just a scratch on the program, clearly trying to signal that this wasn't a major setback for the long term. But even so, it had real consequences for the schedule. The explosion delayed what would have been Starship's 10th test flight. FAA documents had shown that SpaceX was aiming for a possible launch window around June 29th. But now, with Ship 36 destroyed, that timeline has shifted. There's no new official launch date yet, and a replacement upper stage, possibly Ship 37, needs to be completed and tested before the next flight can happen. However, it's important to note that the lower stage of the rocket, known as the Super Heavy booster, is ready. It successfully fired all 33 of its engines in a static test on June 6th. SpaceX has even tested catching the booster with the launch tower's robotic arms, a key part of their reusable rocket strategy. So, once the new Starship upper stage is built, the booster can be paired with it for the next flight. This explosion involved a V2 variant of Starship, a newer version designed with more capacity than previous models. SpaceX is already developing the next generation, called V3, which will be even larger. Their plan for 2025 has been to make this year a major leap forward for Starship. And even with the loss of Ship 36, that plan hasn't changed. The company's development style is often described as fail fast, learn fast. In fact, SpaceX has made a habit of turning failures into progress. Every destroyed prototype adds to their knowledge and improves the next design. That mindset is part of why they've advanced so quickly in such a short time. But there are high stakes involved. Starship isn't just a research project, it's the lander chosen by NASA for the Artemis 3 mission. That mission is supposed to return astronauts to the moon in 2027, so Starship must prove that it's safe and reliable long before that date. Regulators seem to understand the urgency. The FAA recently increased the number of Starship launches allowed per year, from 5 to 25. This is a clear sign that the government is expecting SpaceX to test aggressively, even with setbacks like this one. While SpaceX is doing amazing work with the Starship rocket, they're also quietly making history with their Falcon rockets. In 2025 alone, SpaceX has already launched the Falcon 9 rocket 77 times. That's 77 out of their total 79 missions this year, with the other 2 being Starship flights. They're aiming for up to 170 total launches by the end of the year, which would break their own records. What's even more impressive is how much money Falcon 9 brings in. Each Falcon launch cost clients about $62 million. That means just the Falcon 9 launches so far this year have likely earned SpaceX more than $4.6 billion. And when you include other services like Starlink Internet, rideshare missions, and government contracts, the company's total revenue for 2025 is expected to hit around $15.5 to $16 billion. Falcon rockets have also had some huge moments recently. On June 25th, they launched another group of 27 Starlink satellites from Cape Canaveral. Back in May, a Falcon 9 booster flew for the 28th time and returned safely, setting a new record for booster reuse. These rockets are flying almost every week, with 12 to 14 launches each month, and most of them support Starlink, SpaceX's global internet network. SpaceX is also working with the FAA to raise the number of Falcon launches allowed from their sites in Florida and California. Right now, they're capped at about 50 to 60 launches per year from each site, but SpaceX wants to push that to over 100. Now, shifting from SpaceX to another space story, let's look at why Japan's private lunar lander failed and what that means for future missions. The Japanese company iSpace aimed to land its lunar lander, Resilience, on June 5, 2025, targeting the Mare Frigoris region. During descent, the lander relied on a laser rangefinder to measure its distance from the lunar surface, but the laser rangefinder failed to activate until the vehicle was within 900 meters of the surface. By then, Resilience was descending at about 66 meters per second, far faster than the planned 44 meters per second, leaving no time to slow down. That's it for today's video. Thanks for watching. See you in the next video. At SpaceX's Starbase facility in Texas, every test pushes the limits of engineering. The Starship program is bold, experimental, and moving fast. But when a rocket explodes on the pad, it's a critical learning moment. One of the most shocking incidents happened recently during a planned engine test of Ship 36. The event left the rocket in pieces and raised serious questions about what failed, why it failed, and what SpaceX is doing next. On June 18, 2025, at around 11 p.m., SpaceX began a static fire test for Starship Ship 36. This test was meant to fire all 6 Raptor engines while the rocket remained secured to the ground. These tests are normal in rocket development. Ship 36 had already passed cryogenic tests and a single engine firing. Everything looked ready for the next phase. But during the fueling process for the 6-engine test, things went wrong. Suddenly, 2 explosions happened in quick succession. The first came near the rocket's nose, and the second followed seconds later. A massive fireball lit up the night sky and debris scattered across the pad. Thankfully, no one was hurt. All personnel were safe, and SpaceX confirmed that the area was clear before the test began. After the explosion, SpaceX engineers started an immediate investigation. Within hours, the company released a statement confirming that a major failure had occurred during cryogenic propellant loading. According to the early analysis, the likely cause was a rupture in one of the rocket's high-pressure nitrogen tanks. These tanks, called nitrogen tanks, short for Composite Overwrapped Pressure Vessels, are lightweight carbon fiber tanks used to store gases under very high pressure. In this case, a nitrogen-filled nitrogen tanks inside the nose cone failed below its expected pressure limit. Musk confirmed on his platform X that the failure happened below the tank's proof pressure. That means the tank broke before it even reached the maximum pressure it was supposed to handle. This was a first-time failure for this particular design. What happened next was a chain reaction. When the nitrogen tanks ruptured, it exploded like a small bomb. The blast tore through the payload bay walls and nearby plumbing. These pipelines carried liquid methane and liquid oxygen, Starship's two main propellants. Once the pipes were ripped open, the super-cold fuel and oxidizer mixed in the open air. This fuel mixture auto-ignited almost instantly. That caused the first explosion, which destroyed the upper nose section of the rocket. But the danger wasn't over. There were still hundreds of tons of propellant inside the main tanks. As the fire spread, the remaining methane and oxygen ignited, creating the second and much larger explosion. The resulting fireball damaged the entire test stand, destroyed equipment, and set parts of the launch pad on fire. Let's summarize the event step by step. First, the nitrogen tanks burst under pressure. Second, the blast ripped through pipes carrying fuel. Third, methane and oxygen mixed and ignited. Fourth, the first explosion destroyed the nose. And finally, the remaining propellant exploded in a second, more powerful blast. The cause was clearly mechanical, not human error. And SpaceX quickly explained that the nitrogen tanks used in Starship are completely different from those used on Falcon 9. Falcon 9 uses helium tanks made from titanium, and it has flown more than 75 times in 2025 alone without any problems. The Falcon 9 program continues without delay. Starship, however, is still under development and uses new systems not yet fully proven. This failure is a reminder that Starship is an experimental vehicle. It's built to be reused, operate on methane and oxygen, and fly humans to the Moon and Mars. But every new system carries risk. And SpaceX knows that testing can lead to failure. That's part of the process. The loss of Ship 36 has already caused delays. The test pad, called Massey's Test Stand, was seriously damaged. Its plumbing, pipes, gas pumps, and even control bunkers were hit hard. The flame trench itself, designed to absorb blast force, also took damage. As a result, no more static fires or launches can happen from that pad until it's fully rebuilt. In the meantime, all other Starship testing has been paused. Investigators are analyzing the debris, which is still on site. This makes it easier to find out exactly what went wrong. The FAA is not launching a formal investigation because the event happened on the ground, not in flight. And Falcon 9 operations continue as usual. This failure is isolated to Starship only. SpaceX's recovery plan is already in motion. First, they're rebuilding the Massey test stand. All broken parts are being removed and replaced. They're adding steel floor plates in the flame trench to reduce future damage. Fueling lines and vaporizer units are also being rebuilt. A burned-out control bunker will be replaced. At the same time, SpaceX is checking every nitrogen tanks on every Starship vehicle. If needed, they will replace them all or even redesign the system. One possible change could be moving to autogenous pressurization, where hot gases from the engines are used to pressurize the tanks instead of using separate nitrogen tanks. This method has already been tested on some rocket stages and reduces the number of parts that can fail. SpaceX is also shifting focus to its next-generation ships. Block 2 ships like Ship 36 are being phased out. The company is preparing Ships 37 and 38 for future tests once the pad is ready again. After that, the full focus will move to Block 3, which will have upgrades and possibly new pressurization systems. Experts say the recovery could take weeks or even months. Musk has acknowledged the delay, but remains optimistic. He says that failures like this are expected in an iterative development program. In previous Starship flights, including Flight 7, 8, and 9, SpaceX learned from problems and made improvements. Musk has made it clear that the company will not slow down its testing pace. His vision is to launch Starship as often as every 3 to 4 weeks. Even this latest failure hasn't changed that goal. For SpaceX, each explosion is not just a setback, it's data. And that data leads to better, safer rockets. To move forward from this setback, SpaceX is taking fast and focused action. One of the first priorities is fully rebuilding the damaged Massey test stand. This includes replacing destroyed pipelines, installing new steel plates in the flame trench, and repairing or replacing the burnt control bunker. These upgrades will restore the site and also make it more durable in future tests. SpaceX is also overhauling keypad systems like the quick disconnect arm and vaporizer units. These are critical for fueling operations and must be safe before any new static fires can begin. The goal is to make the ground systems more resistant to accidents and easier to repair if anything goes wrong again. Another essential step is inspecting or replacing every composite overwrapped pressure vessel across the entire Starship fleet. Since the failure began with a nitrogen rupture, engineers must now check each one for possible flaws. If the design itself is found to be weak, it may be reworked or even replaced. Landing rockets on drone ships has become something SpaceX is famous for. It's smart, efficient, and has helped the company save money, reuse rockets faster, and change how space travel works. Now, with the bigger and more powerful Starship, SpaceX wants to take this idea even further. Official plans from SpaceX and the FAA show that the company wants to land future versions of Starship on floating ocean platforms, just like Falcon 9 does now. This idea supports the goal of making Starship fully reusable and ready for frequent launches. So, how will this plan help Starship grow, and when will it actually begin? In the past 2 years, as Starship has completed more test flights, the overall mission plan has expanded too. Documents show that SpaceX wants to launch Starship 44 times a year, from Launch Pad 39A 25 times from Starbase and up to 76 times from Florida's Space Launch Complex 37. These numbers are a sign that SpaceX is aiming to make Starship a regular part of global spaceflight. To make that happen, recovering the rockets quickly and safely is just as important as launching them. SpaceX plans to use Mechazilla, a giant tower with arms that can catch the rocket as it lands at fixed launch sites. This system helps reduce time between launches. But what happens when missions go far away, like over the Pacific or Indian Oceans? This is where drone ships come in. These floating landing platforms allow rockets to land far from the coast. According to FAA documents, SpaceX doesn't want Starship to splash down in the ocean. It makes reusing the rocket too hard. So, like with Falcon 9, they plan to land Starship on drone ships instead. There are big benefits to this. First, it's safer. Ocean landings reduce risks to people and buildings nearby. And if something goes wrong, it's far from land. Even when the landing goes well, the ocean helps absorb some of the energy from the impact. Second, drone ships are flexible. They can move to the best position based on where the rocket is coming from. This makes it easier for the rocket to return, saves fuel, and allows it to carry more cargo. That means Starship could go farther, with heavier payloads and still land safely. This method has worked great for Falcon 9, and scaling it up for Starship could bring even more benefits. Some people wonder if this might interfere with Mechazilla towers, but it actually works well alongside them. Mechazilla is great for quick turnarounds at base. Drone ships are better for long-distance missions. Each has its role. Of course, there are still challenges. One big issue is working with other countries. Drone ships may need to enter the waters of other nations. That means SpaceX needs international agreements. Luckily, they've already started. Falcon 9 has landed near the Bahamas, and reports say Australia may help with landings in the Indian Ocean. More partnerships might come as Starship's range increases. Another challenge is time. Drone ships far from shore take longer to return with a rocket. That slows down the process. To fix this, SpaceX has plans to lower Starship from vertical to horizontal after landing. This makes transport easier and protects the rocket from waves and wind. Then there's the issue of landing legs. Mechazilla can catch a rocket without legs, but drone ships can't. So Starship may need landing legs for these missions. It's extra work, but useful, especially for future Moon or Mars missions where there are no towers. So drone ship landings may be more complex, but they offer major flexibility. They'll be important for missions that go farther and need safe, mobile recovery options. This move also pushes SpaceX to work with more countries and solve engineering challenges, now that will help with planetary missions later. SpaceX wants to start using this system by the second half of next year. Plans already mention multiple drone ship landings in the Pacific and Indian Oceans. These match SpaceX's goal to launch Starship more often starting in 2026. For now, SpaceX is focusing on perfecting tower catches at Starbase. The recent Ship 36 issue has slowed progress, and the Florida launch site is still being built. So expect more Mechazilla landings before we see ocean ones. But once tower systems are running smoothly and SpaceX collects enough data, drone ship missions will begin. To make this work, SpaceX will need new, bigger drone ships. Starship is much larger than Falcon 9, and its engines are stronger. That means these new ships must be tougher and more stable. Some may even be designed to handle more than one recovery before returning to port. And it's not just the ships that need upgrades, the whole Starship system must grow. At Starbase, Pad B is being built. After the big explosion earlier this year, the main pad is being upgraded. In Florida, Launch Pad 39A is being fitted with new systems, and Launch Complex 37 will soon have a huge new platform too. Large production buildings called gigabays will support rapid rocket manufacturing. If all goes well, we could see the first drone ship landings by mid to late next year. Until then, SpaceX will keep working on precise landings and safe re-entry. Once these steps are ready, ocean recovery will become a key part of Starship's journey. This shift is crucial. SpaceX wants Starship to match, or even outperform, Falcon 9. And Falcon 9 just showed how powerful the drone ship method is. On July 2nd, SpaceX launched a Falcon 9 from Florida. It carried 27 Starlink satellites and landed safely on the drone ship, a short fall of gravitas. The booster, B-1067, completed its 29th landing, a new record. Musk confirmed it was the first rocket to land 29 times. That mission also marked Falcon 9's 500th flight, an incredible milestone. It took over 15 years to reach, but SpaceX is now launching faster than ever. In 2025, the company could launch more than 170 times. That's only possible because of reusable rockets and smart recovery methods like drone ship landings. With 3 active drone ships, SpaceX can launch and land rockets quickly. The fastest turnaround time so far is just over 9 days. B-1067 is now only 11 flights away from the company's goal of reusing a booster 40 times. That shows just how strong the drone ship system is. If Starship can use the same strategy, it has a bright future. Once it masters safe landings, SpaceX can send it farther than ever before, maybe even to the Moon or Mars. But first, they need to adapt drone ship operations to fit Starship's huge size, improve how rockets are refurbished, and smoothly connect ocean recovery with the rest of the launch system. It's a big task, but if anyone can pull it off, it's SpaceX. Meanwhile, Blue Origin continues to fall further behind. While SpaceX is preparing for dozens of Starship launches per year, recovering rockets with precision and setting reusability records, Blue Origin is still stuck trying to complete its first orbital flight with New Glenn. The gap is becoming hard to ignore. SpaceX has already delivered over 7,000 Starlink satellites into orbit, executed more than 500 successful Falcon 9 missions, and proven high-frequency rocket reuse. Blue Origin, in contrast, has only launched suborbital flights with New Shepard, many of which have faced delays or setbacks. Their flagship heavy-lift vehicle, New Glenn, has been in development for nearly a decade with no launch yet. And while Starship prepares to land on drone ships in the ocean, Blue Origin hasn't even completed a single booster recovery. Their ambitions sound impressive on paper, but the lack of results speaks louder. In this race to build the future of spaceflight, SpaceX is sprinting ahead while Blue Origin is still tying its shoes. That was it for today's video. Thanks for watching. See you in the next video.